Hello guys, welcome back. And for today's video, we just want to cover the tangent functions and hopefully the whole chapters for our singular functions. Then we can move on to the next section, which is derivative and anti-differentiation. Okay, so for tangent functions, it's essentially just sine theta over cos theta. And with substitution enough points, we get the graph looks like this. Okay. But as you guys notice, for our tangent functions, our period now is pi, and we got so many asymptotes. And the book directly gave us the general solutions for asymptotes. But my personally saying, for the asymptotes, you don't need to remember it. We just look at sine tangent theta, because tangent theta defined as sine theta over cos theta, which means we can directly make the denominator be 0, which our whole thing is not defined. That means when my cos theta equals 0, this will be my asymptotes, which corresponding to all the graphs showing here, negative pi on 2, pi on 2, 3 pi on 2, something like that. Okay. And just remember time range tangent theta, the domain is still R, but exclude all the asymptotes, and the range is R. So for the tangent theta graphs, the period is pi over m, the range is R, and axis of intercept is k pi over m. It's just a pretty basic. Sketch the graph, just make sure you draw the asymptotes and find the x-axis intercept. And again, for example 29, it's like involving like period change and shifting. Okay, pretty straightforward. And for this part, solution of equation involve 29. Remember, for our cos and sine, we read two things, right? Because it's 2 pi. But for tangent, we only need to write one thing, okay? So I will use this example to illustrate my point. Tangent 2x equals square root 3 over 3. So I just need to write 2x equals my square root of 3 is just pi on 6 plus pi times n. I don't need to write anything else because ASTC, I just need to add 180 degrees or pi to get my third quadrant one. So essentially, they are repeating themselves. So I don't need to write anymore. I just need to write one general equation format for the tangent. And it's just like x equals pi on 12 plus half pi on n. Then I just keep plug n's values in to get all the required solutions. Okay, this is again from general solutions. Same thing over here. Okay, we just make this whole thing be theta. Okay, then -1, which means negative pi on 4 or 3 pi on 4, whatever. Then I just keep adding my period to get all the answers. Okay. And 32 again is asked us to sketch the graph involved with dilation, translation, and without reflection. Okay, just dilation and translation. Okay, that's a tangent. This is also pretty important because final exam in 2017 and 2016, I think, North Hemisphere, North Hemisphere to test you guys to draw the tangent line, which is like y equal tangent 2x plus 1, if I remember correctly, and it's 4 marks. So, which means we should really focus on to drawing a quick sketch these types of circular functions. And for example 34, they are the same thing. Okay, if I write sine 2x equal cos 2x, it just means tangent 2x equals 1. Okay, then we just solve it for tangent. Get the idea. So then 6K called general solutions of trigonometry equations, but we actually practice a lot, so you don't need to worry about this part. And we can do it by doing this one. Cos x equals 0.5. Of course, you're going to see, okay, this is really fancy writing. They write like 6n/3, 6n pi over 3 plus minus 3 pi, like, yeah, like this one. So this is essentially just like 2 pi times n, and it's essentially as what I wrote long time ago, pi on 3 plus 2 pi over n, and pi on 3 minus 2 pi over n. Okay, so it's essentially the same thing. And for this part, you don't, of course, comma and belong to z. You don't need to write in the one thing together. You can write two and make it really clear for teachers to catch up with. Okay. And this one is what the cat will give you guys, like n1. It means like general solutions. Okay. N is just like arbitrary constant. And 37, again, the same thing. So for 6K, actually we covered a long time ago, and we don't need to spend any time on 6K. But you guys need to make sure you can, and you are able to write the general solutions. For 6L, they just applications. Okay, this is pretty important because finally we link what we learned to the real life. And to help you guys to familiar with this type of question, let's just go through one example in details. The first sinusoidal functions. Okay, this is important for you guys to remember. Okay, and a wheel mounted in a wall and rotates such a distance a particular point on the wheel from the ground given by this guy. How far the point P above the ground when t equals 0? Basically substitute t equals 0 in, we get the answer, which is 40 centimeters above the ground. And for our period, again, we use 3/2 to get the period, 2 pi divided by 4 pi on 3 to get the period. And then they ask the maximum and minimum distance, which make sure that my cost value is -1 and 1, okay, because our t is any value is greater than or equal to 0, so I can keep going. And they ask us to sketch the graph. It's essentially just like this one, with cos 4 pi on 3 over t, then dilation factor of 60, then we take reflection negative, then we add 100 upward. And in the first rotation, when the interval time when p is less than 70, so basically it's just like for the first rotation, just like until here, okay? So you have to make sure it's less than 70. It should be about this time to this time, okay? This is pretty straightforward, but it's essentially the circular functions applications, and it's what we do for our final or second exam. Sometimes we more with like the high tide or low tide for the ocean or for the sea, or sometimes we involve with like the clock, or even like in 2017, I think final year exam involved with like the Melbourne Star, the wheel, like the shape, then involve with circular functions, and you have to link later cover topics like derivative to get all the ideas. Okay, and again, let's look at question 39. It's just like a hat. See, above the mean sea level is like the sine curve, right? And sometimes we're gonna make some adjustment, like it must be above like 2 and below to 3. Okay, it will be the safe for our young kids or for people to swim, play with. So technically for the whole day, you only have certain times, you can enjoy the water or the beach, right? So this is can be linked to our essential exactly solutions, and also linked to the time interval available. And some word you should remember, like high tide, or like the cross of the harbor bar, or something like that. So you have to be familiar with this word used in such scenarios, okay? And of course, another one is the timing things. Okay, AM, PM, then how to convert in the 0 to 24 hours, okay? So this is pretty much about for 6L. And for our whole chapters, again, our essential part is familiar with the ASTC to convert special angles with each other and how to find general solutions. And the last but not least is graphs. Okay, because sometimes we have to use graphs to help you guys to determine which part of the session we want, especially when we do the applications. Okay, that's pretty much for this chapter 6. And for next lesson, I will quickly go through chapter 7 because it's more like the revisions. And then we can move on to the derivative and anti-differential, which is another part of math method calculus. Okay, thank you guys for watching and enjoy the day. See you guys for the next videos. Bye.